240.50 Plug fuses. Paragraph A. Maximum voltage states that plug fuses are permitted to be used in circuits not exceeding 125 volts between conductors, or in circuits supplied by a system having a grounded neutral where the line to neutral voltage does not exceed 150 volts. 240.60 Cartridge fuses. Paragraph A. Maximum voltage states that cartridge fuses and fuse holders of the 300-volt type are permitted to be used in circuits not exceeding 300 volts between conductors. Let's consider a 220-volt line in a residential application fed to a 2-fuse disconnect. It would comply with 240.50 paragraph A, subparagraph 2 because the line to neutral voltage does not exceed 150 volts. However, it would not comply with 240.50 paragraph A, subparagraph 1 because the voltage between conductors exceeds 125 volts. 240.50 paragraph A does not explicitly state that both conditions must be met. The exception to 240.50 paragraph A clarifies this point, stating that plug fuses rated 125 volts or less are permitted to be used in circuits having a grounded neutral and not exceeding 250 volts between conductors. Therefore, plug fuses rated 125 volts or less can be used in this scenario because the circuit has a grounded neutral and the voltage between conductors does not exceed 250 volts. The voltage limitations for plug fuses and cartridge fuses are based on their design and construction. Plug fuses are typically designed for low voltage applications, while cartridge fuses are designed for high voltage applications. The higher voltage rating of cartridge fuses allows them to handle larger currents and interrupting capacities. Fuses are overcurrent protection devices used in electrical circuits. Their primary function is to protect the circuit and its components from damage caused by excessive current flow, which can result from overloads, short circuit, or ground faults. When the current exceeds the fuse's rated capacity, the fuse element melts, opening the circuit and stopping the current flow. There are several types of fuses, each designed for specific applications and voltage levels. Plug fuses are one type, commonly used in residential and light commercial applications. Cartridge fuses are another type, often used in higher voltage and current applications. The voltage rating of a fuse indicates the maximum voltage the fuse can safely interrupt. When a fuse is subjected to a voltage higher than its rating, it may not be able to effectively interrupt the circuit, potentially leading to dangerous arcing or equipment failure. The National Electrical Code, or NEC, sets the standards for electrical installations in the United States. It provides guidelines for the selection and use of fuses, including voltage ratings, to ensure safety and proper protection of electrical systems. 240.50 of the NEC specifically addresses plug fuses, outlining the conditions under which they can be used based on voltage levels. Plug fuses are typically used in circuits with relatively low voltage levels. NEC 240.50 paragraph A, subparagraph 1 limits their use to circuits not exceeding 125 volts between conductors. This means that in a standard 120-volt system, where the voltage between the hot and neutral wires is 120 volts, a plug fuse can be used. The code also permits the use of plug fuses in circuits supplied by a system having a grounded neutral where the line to neutral voltage does not exceed 150 volts, as stated in NEC 240.50 paragraph A, subparagraph 2. This provision allows plug fuses to be used in certain 240-volt systems, particularly those found in residential settings. In a typical 240-volt residential system, the voltage between the two hot wires is 240 volts, while the voltage from either hot wire to the neutral wire is 120 volts. Because the line to neutral voltage is 120 volts, which is less than the 150-volt limit, plug fuses are permitted in this application provided the system has a grounded neutral. The exception to 240.50 paragraph A further clarifies this allowance, stating that plug fuses rated 125 volts or less are permitted to be used in circuits having a grounded neutral and not exceeding 250 volts between conductors. This exception recognizes the common configuration of residential electrical systems and allows for the use of plug fuses in these systems under specific conditions. The voltage limitations for plug fuses are primarily based on safety considerations. Plug fuses are designed with a relatively simple construction and a limited interrupting capacity. When subjected to higher voltages, their ability to safely interrupt the circuit is compromised, increasing the risk of arcing, fire, and electrical shock. By limiting the voltage levels at which plug fuses can be used, the NEC aims to minimize these risks and ensure the safety of electrical systems and the people who interact with them. Cartridge fuses, on the other hand, are designed for higher voltage and current applications. They have a more robust construction and a higher interrupting capacity compared to plug fuses. NEC 240.60 addresses cartridge fuses, specifying the conditions under which they can be used based on voltage levels. Cartridge fuses and fuse holders of the 300-volt type are permitted to be used in circuits not exceeding 300 volts between conductors, as stated in NEC 240.60, paragraph A. This provision allows cartridge fuses to be used in a wide range of applications, including many commercial and industrial settings. The higher voltage rating of cartridge fuses allows them to handle larger currents and interrupt circuits with higher fault currents. This makes them suitable for protecting equipment and systems that require more robust overcurrent protection. The design and construction of cartridge fuses contribute to their higher voltage rating. They typically have a cylindrical body made of glass, ceramic, or fiberglass, which provides insulation and mechanical strength. The fuse element is enclosed within the body and is surrounded by an arc-quenching material, such as sand or silica. When the fuse blows, the arc-quenching material helps to extinguish the arc and prevent it from re-establishing, ensuring a safe and reliable interruption of the circuit. The choice between plug fuses and cartridge fuses depends on the specific application and the voltage and current requirements of the circuit. In general, plug fuses are suitable for low voltage, low current applications, while cartridge fuses are better suited for higher voltage, higher current applications. When selecting fuses, it is important to consider not only the voltage and current ratings but also the interrupting capacity. The interrupting capacity is the maximum fault current that the fuse can safely interrupt without causing damage to itself or the surrounding equipment. Fuses with a higher interrupting capacity are better able to handle high fault currents, providing better protection for the electrical system. In addition to voltage ratings, fuses also have current ratings. The current rating is the maximum current that the fuse can carry continuously without blowing. It is important to select a fuse with a current rating that is appropriate for the circuit it is protecting. If the fuse is rated too low, it may blow unnecessarily, causing nuisance tripping. If the fuse is rated too high, it may not provide adequate protection in the event of an overcurrent. The NEC provides detailed guidelines for selecting fuse sizes based on the ampacity of the conductors and the characteristics of the equipment being protected. It is important to follow these guidelines to ensure that the electrical system is properly protected and that the fuses will operate correctly in the event of an overcurrent. In summary, the voltage limitations for plug fuses and cartridge fuses are based on their design, construction, and interrupting capacity. Plug fuses are typically limited to lower voltage applications, while cartridge fuses are designed for higher voltage applications. The NEC provides specific guidelines for the use of fuses based on voltage levels, current ratings, and interrupting capacity. By following these guidelines, you can ensure the safety and proper protection of electrical systems. Remember to always consult the NEC and other applicable codes and standards when working with electrical systems. If you are not qualified to perform electrical work, it is important to hire a licensed electrician to ensure that the work is done safely and correctly. Understanding the voltage limitations of fuses is crucial for ensuring electrical safety and proper circuit protection. By adhering to the guidelines provided by the NEC and selecting the appropriate fuses for the application, you can minimize the risk of electrical hazards and protect your electrical systems from damage.